Hello everybody, it's Adam here, coming back to you from Houdini 18, and today we're going to make smoke fall down a hole. Let's start off with a box, and we'll move to our pyro, and we will control click billowy smoke. Let's head up one level, and we'll rename this to Geo Smoke Fall, and we'll dive inside. Actually, let's go ahead and turn that off so we're not seeing the result of that just yet. So the concept is basically we're going to let gravity pull smoke down through a hole in the floor. So we'll start off by making a box. We're going to need a tube. We're going to need Boolean. And we'll need a merge. So we'll connect these together and start configuring our geometry here. The box is going to be 4 by 0.1 by 4. The tube here is going to be a polygon with 72 columns, so we get a nice smooth round edge. The radius is going to be 0.7. And if we look at our Boolean here, we have a hole in the floor. Great. That's a good place to start. So now what we want to do is add a ring around this hole that will emit smoke. And we can do that with a circle over here. And the circle is going to be do the same thing. It's going to be a polygon with 72 divisions. And we'll set it to a little bigger, 0.75 along the z-axis. And now we can see it's actually inside of here, so we need to say 0.15. We're bringing it up above the ground just a little. And I've got a little bit of a gap here because smoke and volumes tend to expand from the generator of them. Here's a little trick I've been using. I'm just going to throw down a torus here, and we're going to set the rows to 48 by 96, and we'll drop down a normal, and we want that on points because we're going to transfer that to the circle. Trib transfer. And plug that in. Take a look to see how our normals are looking. They're looking okay, but we need to make this an open arc. There we go. So you can see our normals are kind of pointing up, and that's because we need to set this center equal to the circle center. And you can use this to move your normals up and down. What we want to do with this, we'll throw away this box here, is we have to supply a surface to create density. So we're going to need a poly wire to do that. And now that we have our poly wire, we'll set this to 0, 1 with 6 divisions. And now we have our normals all pointing in on the poly wire, and we're just going to use the old trick v at v equals at n to make our velocities move inward. And just because we may need to adjust this later, I'm going to make a transform and call it tweak. And I think we're ready to go here. Create density. We do want it to be very dense, so I'm going to set the scale to 10 inside of the pyro source instead of increasing it later inside the DOP network. Shift A, drag up, pull this over, and our network is looking a little better. One thing we want to do on rasterize here is, let's just move our display flag down here so we can see what we're making, is we want our coverage 0.85 And what's our particle scale? Got a little cheat sheet here. Polywire, there it is, 0.34. This is the big one here, 0.34. And you could affect this change using p-scale as well. Let's move our mouse here, press the D key, and we'll choose the darker background so we can see everything. Okay, so that kind of looks like it. So what we want to do, here's a little trick you can do. If you've got multiple stacks inside a single object, you can just move the display flag, and then the shelf tool up here will operate upon that. So we'll just move to collision, create a static object. We'll dive in here, press the L key to lay it out, and if I turn that off and go inside, I can indeed see that I've got a smoke ring and a hole with a collision object. So let's turn off this and set up our box size in the pyro itself. Now I think I have some magic numbers for this too. 2.35, 1.78, 2.35, and then our center here will be negative 0.65. And notice what happens here. We've got this area below where our smoke can drop into. So that's where all our volume is going to appear. Now if we run this, we'll see that nothing happens. It kind of does its thing, but it's not behaving the way we want. And it's not, if we go in here and zero this out, let's just go to shape, and we'll turn everything off. Make sure combustion is off, and we'll just zero all this out. Rewind, and now we just get smoke that builds up. I mean, it's kind of colliding, but this falling is not necessarily due to this gravity, because if we look here in our advanced, you can see we have gravity ignored, and we want gravity to be honored. So now you can see gravity really has an effect on our smoke. So let's go back and turn on dissipation and set this to maybe 1.9. We've got to find a way to kind of make this fade out before it hits the end of our box. So maybe we want to go up to like 2.6, and that was it. It's kind of nice so that we can adjust it while it's running. There's 2.2, and that's pretty much it. So let's go to our div size on the pyro box, press the up arrow to stop playback, rewind, and we're going to set this to 0.2, and we might as well leverage OpenCL on the pyro solver. As long as you keep your voxel count fairly low, your graphics card can help speed things up. And even though it looks like, it's gotten slower with enabling OpenGL, I've actually added more quality to the sim, and that's why it's running at nearly the same speed. So let's remove our collision object, and we can see we've got some buildup here around the edge. And if we let that run, you can see it is going to hit our boundaries and just become a square, which is not going to help us sell the effect. It also is a little high here, so let's go back to our smoke fall, and maybe we can use this tweak that we dropped in. Let's see, just to bring it down, 0.06. There we go. So our polywire is a little closer to the floor now. We can turn off these normals. To keep the smoke from expanding, we can just refine our collision object here. So I'm going to right click on this tube, actions, create reference copy, and that will give me an exact copy of that. But we want to break the radius scale, so we'll delete that channel, and we want to break end caps, delete that channel, because we need a hollow tube, not a solid tube. So I'm going to increase the radius scale out a bit, and then we'll drop down a poly extrude, and we'll take that poly extrude here and make sure we have output back on, and we'll just kind of crank it out a little, drop it into our merge down here, and if we take a look, that's going to be the range. So you determine how far. You could even animate this maybe. If you wanted, say, maybe it wouldn't be this, you'd have to bind both the tube size here along with your poly extrude. So play around with that. If we take a look at our collision object in general, it looks pretty crunchy. And by default, if we go to our collision source under the volume tab, you can see that it's linked to our div size. I really don't like that default. 0.1, 0.01 gives us a nice clean collision object. So with that in mind, we can head back out into here, rewind, and once again we can see that our smoke is falling into the hole and it's not expanding beyond that collision inner wall that we set up. So there we go, we've got a hole in space. Let's continue with refining this for output now. Some of the new render systems that are out there will render VDBs directly, and you can kick those out of Houdini. And what a lot of the shaders offer in these third-party render systems, and in Mantra as well, is the ability to detect a heat field. Often when we look at this, we have all these fields, temperature, heat, fuel, but we know because we're not using combustion that heat and fuel are blank basically, but it's still giving them to us. So what we want to do is just drop down a delete here, and these are primitives. We'll middle click again, 7.7 primitives, 0, 1, 2, 3, 4, 5, 6. So density is 0. We'll just delete 0, then choose non-selected, and now we just have density. Let's go ahead and drop down a convert, and we want to convert this to a VDB. You can see their volumes now, and if we convert them to a VDB, they'll be available for rendering in third-party packages. And now you can see we have one VDB. But we've lost heat, right? Temperature and velocity. Let's drop down a VDB diagnostic. This is a new node I've been playing with. And what it does is it lets you validate and mask out parts of your VDB, kind of like you would mask out anything. So I'm going to turn on mark mask, turn off finite, and in my experimentations, if you activate uniform background, it helps clear things out. I'm going to set this to 0.5. And we need to, does it rewind? We have our mask. What is the trick to the, oh, we have to turn this on. So now we see that this 0.5 can allow us to mask out. These are Boolean on-off values inside our field. So we might say, okay, these could represent our heat field. Let's go ahead and do that with a split here. Now, because I have set mark and I've set make a mask, if we middle click, you'll see I have a new field called density mask, but it's of a type Boolean, which is a strange new type that I've never worked with, and I got some help from side effects. So here's how you leverage it. And so we'll go to a split, and we'll split by density, and then we'll use a VDB combine to connect those two together. And what we want to use for operation is activity intersection. And notice that how this box jumped up. So if we drop down a volume viz, and we'll quickly set that to density, and we'll drop in our original density. You can see it extends down farther, and then I move this here, it gets shorter. So really the only thing we have left to do here is drop down a name node, and we'll just rename density to heat. We have density, which has been masked as density. We rename it, it's now heat, and now we can just drop down a merge, followed by the volume visualization, which now should offer heat. It does, and if I were to choose the black body, you can see here that I now have a fake heat field, but I'm not paying the penalty of having these extra combustion fields in my file, which is another thing we'd probably want to do here. We'd want to do a file cache and make sure you change the file extension to VDB. Now if I were to write this out and send it off to another render system, the person rendering it would have the option of supplying this heat field to their volume shader and getting a little extra look, a better look out of it, and being able to add colors inside. So with that, I'm out. Have some fun, play around with it. Smoke falling into a hole with a fake heat field, and I'm out.